and this is my final presentation for the cloud computing class. The technology that I'll be talking about is the Azure API Management tool. Azure API Management is both a gateway and portals. It is a gateway in that it can connect to any service via that service's API. It is a publisher portal that allows somebody who wants to publish an API to add a layer in front of that API to monitor use of the API, the number of calls, where they're coming from, how quickly there's response. It allows you to control access to your service and to cache responses to improve performance and to save hits from going all the way back to that backend service. And there's a lot of other things it can do as well. It's also a developer portal, so there's an auto-generated API catalog, and it's great. It's got documentation and code samples, so it makes it very easy to develop against these APIs. It even allows you to try out the API interactively and to do self-service API key management with various identity providers, and it allows you to publish your application after you've written an application that uses the API. So this is a picture of how it looks. So you have your original service, the backend service that has an API, and you publish that API in the Azure API Manager. And then there's an API, a new API from that API Manager, and then these other applications talk to that API, and each application may be controlled in a different way with different amounts of bandwidth and number of calls per month or per minute and so on. So I tackled two problems. As a test run or to get started, I used a simple calculator API, and then I did what I really wanted to do, which was to create a weather application. And for the back end, I used the dark sky source of data. And I wanted an application where I could give any date, past, present, or future, and then show a table with the weather in 7 cities that are of particular interest to me. So my steps were first to find a service that had an API, and then register that API with Azure API Management, go into developer mode and test the API, learn how to use it, write a couple of different programs that both use the API, and then go back into administrator or publisher mode to monitor usage of the API. Then I wanted to get into the problem I was really interested in, which is weather. So I identified a weather data source, registered that weather data source's API in API Management, and then created a new, what they call product level in Azure, which is a way of controlling access. And finally, I wrote and published the web application about weather. So this is one way in which you can define API. This is called Swagger. It's a little language in which you can express the information about the operations and parameters in an API. And this is a selection from the calculator API that I used as my first test case. So you start off by creating an Azure account and then an API management instance. You import the API. Fortunately, this calculator API provided a very nice specification in Swagger or JSON format. There are other specification formats like Waddle, which is more XML-like, but it was nice because you could just import this directly. You didn't have to do any futzing around with it. And then it's in there. And now it's possible to test this new API. Now this is the API that is coming out of the Azure API Manager. And it's really cool because you can actually try out the API right here. You can put in the parameters that you want, like here we're going to be adding two numbers, 199 and 2 in this calculator. And you can see things like what the request is going to look like, the HTTP, the URL, and so on. And then you hit send, and you get a response back with a value. And you can also take a look at a lot more details about what happened in that exchange. So that's testing it from the API Manager. You can also get code snippets in 8 different languages, which as a developer really helps you get started in writing your application. So next I created a developer account and subscribed to a product that is basically a definition of how much bandwidth I kind of can get out of the API. So I signed up for the starter product. And in the starter product, I had already published the basic calculator API. So I subscribed to that. And now I can see in my developer dashboard a lot of information, including my subscriptions to the starter product. And I can show my key, which is important when I'm developing the application. I need to be able to have the key in order to successfully get back to that through the API from Azure back to the backend API. And I haven't developed any applications yet here. So I went ahead and I wrote a Python script that would call the API. So it is using Python's HTTP lib and going to the API that I set up on Azure. And it constructs the URL with the operation, the arithmetic operation, and the arguments. And so you feed those into the Python script. In this way, you can say python test.py, which is the name of the program, and then you give the arithmetic operation you want to do on the operands, and the program feeds you back 7 after having gone through all of these steps back to the original service. So it's working, which is very cool. Then I wanted to create a second application using the same API, and I did that in R, and I used RStudio, which is a development environment for R, to create an R web app. And there's this really nice facility where you can create this project, and it sets you up with a default set of code that you just have to change. There's UI code and server code. So I figured out that I needed to use the HTTR library in R, and because the results from the calculator server come back in XML and I wanted to interpret them, I used an XML library. And of course the Shiny library, which is the web application library. So I wrote the code, including the key that I got as a developer, both the UI and the server code, and I tested it within RStudio and saw that it was working. So I can pick my operation and my operands, and it will return to me a result. I also was able to confirm that the rate limits that are imposed by Azure API Management work. So in this case, I could not, I had set a limit through the starter product that I could not make more than 10 calls, or maybe it was 5, in 1 minute. So I don't have a very graceful error message here, but at least I was able to confirm that the throttling that is imposed by Azure API Management works. I then went ahead and published the web app on a public place to publish a hosting website and confirmed that it worked there. Then I went back to API Management as the developer and registered this calculator application. And then as publisher, went ahead and approved publication of that application. And now the general public can go to the API Management website and find this application and run it. You can monitor usage, see the geographic source of calls, and all of that. So now I wanted to get on to actually developing the weather app. So I'm pulling data from the Dark Sky API. So I register that API with Azure, and I did not find a Swagger definition, so I manually added the API operation after reading the Dark Sky documentation. I confirmed that it works through the awesome Azure API Management tool, tested it, it's fine, I get an answer back with data information. I then created a different product that allowed an intermediate level of number of calls per unit time. Now as the developer, I go in and subscribe to that product, and then I write the R application, basing it on my calculator application, but making changes so that I can get the new functionality that I want, publish that to shinyapps.io, and here's my application. So I see 7 cities that I care about because my family lives in them, and I can see them all at once, what the weather is, and min and max temperatures, on any given date, and this is yesterday. So then I register the application with the API management and publish it as publisher, confirm that the general public can see it. So that's pretty much it. It is also possible to monetize your application easily through by using the Azure API Management. I did try out caching so that I wouldn't go back to the backend service more than I needed to. In summary, the Azure API Management tool is three things. It's an API proxy, a publisher portal, and a developer portal. I used it to write a weather app that was written in R, published on shinyapps.io, and also in the API Management tool. It uses the weather API that I published on API Management tool, which is a proxy for the backend data coming from Dark Sky, and I was able to limit access and cache. I hope you enjoyed my summary of my project. It was a lot of fun. Thank you very much. Oh, I guess I could do my demo. Great. So here's what it looks like when you go to the my portal, Cloud Harvard portal. You can see the applications that I developed. Here's the simple calculations one, which takes you to the application, where I guess you wait for a while, and then you can go ahead and supply the information, the parameters, and get a result. You can also go back and test out the weather application, also hosted at shinyapps.io, and fill in any date. For example, we could see what the weather is going to be like on Christmas Eve in different cities. We can see what the weather was like when I had my first child, which was a while ago. Pretty cold in Cambridge. And then here's what the dashboard looks like for the Azure portal. So if we go to the API Management Service, Cloud Harvard, we can see that there's both the publisher portal and the developer portal. And the publisher portal is where you define the APIs and control access and so on. And the developer portal is where you can check out the different APIs and try them out and see what code you can use to call them and so on. So it's super cool. Hope you enjoyed it. Thanks a lot.